Let's have a look at this exercise. So this exercise is designed to derive the confidence interval on the population mean, mu, when the population variance, sigma square, is unknown. So in this case, we're going to use t distribution instead of the z distribution. So the contents of 7 similar containers of sulfuric acid are 9.8, 10.2, 10.4, 9.8, 10.0, 10.2, and 9.6 liters. Find the 95% confidence interval for the mean contents of all such containers, assuming an approximately normal distribution. So for the population mean, we have, if the population variance sigma square is unknown, then we are going to use the t distribution, that is plus t alpha over 2 m minus 1, and then instead of sigma, now we have s over square root of n, and then greater than x bar minus t alpha over 2 m minus 1 s over square root of n. Now, in this case, we need to find out t alpha over 2 n minus 1 x bar s and n. So what is n? N is the sample size. Sample size is 7 containers, so n equals to 7. We need to compute s from this sample data, and alpha over 2, because it's 95%. So 100, 1 minus alpha percent confidence interval. This is 95%. Okay. So alpha over 2, alpha will equals to 0.05. Alpha over 2 will equals to 0.025. Then what we need to derive is, okay, t 0.025 and n minus 1, n equals to 7, so n minus 1 is 6. So t 0.025, 6, what is this critical value? Now let's go back to the book, the appendix table, 8.4 t distribution. So we know that t distribution is also symmetric. We need to find this t 0.025 and 6.025, 6. So this is a right-tailed, so we can directly use this value. This is 0.025. This is 6 degree of freedom. Now the value we want to find is 2.447. So over here, this is 2.447. Now we need to find x bar sample mean and the sample standard deviation using this data. Now let's get Excel. So the data, let's put the data into the Excel. 9.8, 10.2, and then 10.4, 9.8, 10.0, 10.2, and the last value is 9.6. 9.6. So let's check how many of them. So we got 7 rows, right? And this is the sample data. Now let's find the mean. Okay, so this will equals to average. It should be average. Average. Let's get this value. So this will equals to 10. So the sample mean will be sample mean x bar. Now let's get sample STD. This will equals to STD. This is based on entire population. This is based on sample. So let's use this. And we got sample standard deviation is 0.282843. Let's take the 3 digits. And this will be 0.283. Okay. Now let's go back. The standard deviation will be 0.283. X bar is 10.0, and we know this T alpha over to n minus 1 is 2.447. So the 95% confidence interval for the mean content of all such containers, that's a population mean, will be X bar plus minus T alpha over 2 n minus 1 S over square root of n. So this will be 10.0 plus minus 2.447.283 equal to square root of 7. So after calculation, this will be mu will be in the range of 10.26 and greater than 9.74. So this is a confidence interval, 95% confidence interval for the mean contents of all such containers. So this concludes our exercise for confidence interval on the mean mu when population variance is unknown. So in this case, we replace the population standard deviation with the sample standard deviation. And because we did such a replacement, then we use the t distribution instead of the z distribution.